Alright, we are going to look at congruence and how it applies to shapes and especially triangles. Thinking about segments or angles, things that we've looked at before, those were congruent if they had the same shape and size, and it's the same thing with polygons. We can see that with these trapezoids over here, they're all congruent even though some of them are rotated or flipped from each other. That's okay. They are still congruent, where these on the right that aren't congruent, these two are the same shape but different sizes. This one is a different shape than the other two, so none of them are congruent. Okay, so when you write a congruent statement for two polygons, we always list the corresponding vertices in the same order. That means we can write them in more than one way. There's two different ways down here. Let's take a look at the first way. The first point that is listed here is A, and the first point that's listed here is F. And if we look at the triangles over here, we can see that A and F are congruent. So they match up. They're both first listed. They are congruent. The second points listed are B and E, and they are also congruent. Similarly, C, D, the third points listed, are the third set of congruent triangles. So it doesn't matter which order we write them in as long as the two triangles are written so that the congruent angles match up. Another cool thing about these congruent statements, let's take a look at the second statement over here, is that if we look at two of the points like CA, the second and third, and then DF are the second and third, that means that those two segments, CA and DF, should be congruent. And we can see that CA and DF are indeed congruent. Okay, so let's try writing a congruent statement from scratch. We've got these two triangles here. All of the angles are corresponding and congruent. All of the sides are congruent to each other. So these are congruent triangles. We just have to figure out how to write the congruent statement to tell other people that they're congruent. The way I like to do it is to take a look at the angles that have just one arc. So those are K and S. Those are congruent. Let me make a note of that. K is congruent to angle S. Now let's go to two arcs, which are L and R. And those are congruent. L is congruent to R. And the last set, that means that J and T are congruent as well. So I can use these congruence statements to write my triangle congruent statement. And it doesn't matter which order I write the first triangle in, but once I do, that will determine the order I write the second triangle in. So for instance, if I just go right down the line and go triangle KLJ is congruent to triangle, this means that I have to make sure that the order I write these next points matches up. So K is our first one. K is congruent to S, so the first point should be S. The second point is L, which is congruent to R, and the third point is J, which is congruent to T. So that is the triangle congruence statement. Now I could have written it a different way, but there's a bunch of different ways you could do it. I just want to make a note that we can still look at sets of points in this congruence statement. So KL and SR are the first 2 points in both of them, and we can see that those two segments are also congruent. So that's just a nifty way we can use this congruence statement. Alright, let's look at one last example. In this example, we've got these two quadrilaterals, and we're given that DEFG is congruent to SPQR. We're going to use that information to find the value of x and y, which are variables in these expressions over here. One of them is a length, and one of them is an angle measure. So let's find this length first, this QR. The way we can do that is by taking a look in the congruence statement and finding QR, which is right here. So pause a second to think about what the corresponding segment is in the other quadrilateral. Okay, so Q and R are the third and fourth points. So the third and fourth points of the other quadrilateral F and G are going to be the corresponding points. That means that GF, or FG right here, is going to be congruent to QR, which is right here. We can use that information to write an equation. So if there's a congruent, the lengths are equal to each other, and we've got that 12 equals 2x minus 4. From here we can just solve for x, so that will be good for part A. Let's add 4 to both sides. 16 equals 2x, divide by 2, we get that 8 equals x. To find y now, we can figure out which angle is corresponding to angle Q, because this expression here is angle Q. So take a second to think about which angle corresponds to angle Q, which is right here in our congruent statement. Alright, so that's our third point. That means angle Q is going to correspond to angle F. And looking for it in our picture, we find it right here. So that angle's got to be 68 degrees. Okay, so if those two angles are congruent, then we can set up an equation, 6y plus x equals 68 degrees. Now we just found what x is, it's 8, so we can substitute that in, 6y plus 8 equals 68. And that's why I found QR first, because it only had that x, and now using that x we can figure out what y is. Here we can just solve, subtract 8 from both sides, we get 6y equals 60. Dividing by 6, we get y equals 10. And that's it.